Well, as you heard in Colin's newscast, it's been a bad week for poultry producers in 29 farms here in Ontario. They're all under quarantine after H5 avian influenza was confirmed on a turkey farm near Woodstock. About 10,000 birds have died from the virus, and another 35,000 were euthanized to stop the virus from spreading. While the virus is fatal to poultry, certain strains are equally deadly to humans. But there's a new tool created by researchers at the University of Guelph that could make it easier for farmers to contain the disease. Assistant Professor Suresh Nitharajan joins me now with the details. Good morning, Suresh.
Good morning, Craig.
So, what happens to a bird? Explain that first. When a bird has avian flu, what happens to it?
So basically, when it gets infected with pathogen, it could be a low pathogen versus a high pathogen. If it's a low pathogen, it comes and goes. So it's very typical, and farmers are aware of it. It exhibits primarily changes in feeding tendencies. But when a high pathogen such as this H5N2 occurs, it threatens the poultry. There is a possibility of contagiousness. Not here in North America, although it's rare here. It has happened in other countries such as Asia and also in Africa. There is a possibility of pandemic nature from the birds to the humans. So it's more of a respiratory infection. So the birds cannot breathe freely. It has restricted the ability to feed. And also, it cannot take up water, and then eventually, due to the restriction in the immunity, it slowly it dies. The bird dies.
What can a farmer do, Suresh, to stop the disease before it ends up killing his entire flock?
So it again depends on the infection level and also the type of the subtype or the strain level. For example, if it's a low pathogen, farmers could possibly follow very simple strategies, especially in spring season when they allow the birds to move out and interact possibly with waterfowl such as ducks and geese. That could be avoided because the primary cause of infection comes from wild birds to the domestic birds.
Oh.
So that is one way to prevent. But changes in feeding patterns and also practicing sanitation procedures in a much more efficient manner could possibly reduce this infection. And also there is a possibility to use vaccines. But vaccines has its own disadvantages. Sometimes it works. Because of the resistance, there is a possibility that vaccines may not work.
And this strain that we're talking about right now, what effect does this one have on humans?
The possibility of contagiousness from the bird to the human is very less here in North America. But, for example, H7N1 and the other strains, high pathogenic strains, when they get infected from the birds to the humans, humans also has problems in breathing, especially respiratory tract infection, infection in the lungs. So I would say up to 300 people have died because of high pathogenic strains in the world since 2003. This is based on the World Health Organization report.
I want to get to your tool in just a second, but let's talk about right now. How do farmers test for the virus right now?
So there are a couple of tests. Right now, farmers take swabs from the throat of the birds, or veterinarians go and then take blood samples from the birds, and then they ship it to facilities such as the Animal Health Laboratory here at the University of Guelph. So there are a variety of tools. One is the virus isolation technique. It is a very sensitive technique, but it takes about 3 to 8 days to understand what type of strain or what type of virus is causing that particular disease. So there is another advanced tool called RT-PCR. It's basically real-time polymerase chain reaction, which takes about 5 to 8 hours. That's the most efficient tool currently in the laboratory to be able to come to a conclusion regarding the subtypes and the strain types. So again, if the farm is say, couple of hours from the big cities, and they have to ship the samples from the farm to the facility to be able to test it. So if it's a throat swab, it's okay. If it's an environmental swab, it's okay. If it's a blood sample, you would need specialized chambers to be able to transport the sample from the laboratory to the animal health facilities.
So let's get to your tool, Suresh. How will your new tool make the disease easier to identify and obviously therefore contain?
Number one, I would say it's a real-time monitoring. So you could do the test right away in the farm itself. And also the time is of crucial. So it is very easy. Probably within 3 to 5 minutes, you would know the results immediately. And there is no need for labels or dyes or special chemicals to be able to determine what is causing the, what type of substrain or the virus species is present in the sample. The unique ability to detect multiple strains at the same time, and also the possibility to classify and discriminate between high pathogen versus low pathogen strain in a real-time manner is the unique advantage of our invention.
So we're basically out of time, Suresh, but I want to know how does someone use your kit?
It's very user-friendly. You basically mix specific buffer solutions. The chip looks like a transparent portable cartridge. Even a farmer without any specific technical expertise could be able to deploy the tool right away in the farm and then check it. So there are two types of output, I would say. One is a colorimetric. Just a color change would say whether it's an yes or no, more of a binary test. But also it has the additional functional module of understanding what specific pathogen is causing that particular disease, whether it's a human-based pathogen or a low pathogen or a highly pathogenic virus strain. So the ability to discriminate is the key of our invention, because the device also can possibly reduce the potential for laboratory overload during the course of an outbreak, such as what we experienced recently. So it has a tremendous potential to ease the load of the government safety inspectors, and also as a friendly tool for the Canadian poultry farmers.
When are we going to see these kits being used, do you think?
So we are in the validation stage, so hopefully pretty soon. So if everything goes well with the performance assessment, we are pushing to bring it to the hands of the farmers as soon as possible.
Suresh, thanks so much for talking about this.
Thank you, Craig.
Suresh Neetharajan is an assistant professor at the University of Guelph. He and a few of his colleagues are responsible for developing a new method of testing for avian flu.